Hi. So it kind of seems like a while since I've done one of these, but I thought it might be helpful for some people. So I am going to talk a little bit about factor trees today. The first thing we have to think about when we're looking at factor trees is factors and multiples. Okay. So the first thing we have to remember, and I'd take a note of these in your book, okay, a factor is a number, now this is the nicest way of saying it, a number that goes into another number. I'm going to write it like that, but if you want to use different words, that's absolutely fine. So a factor is a number which goes into another. Oops. Another. Dear, spelled number wrong there. Oh dear, I think I'll just start again with number. I spelled it completely wrong. Into another number. There we are. Don't do that. So for example, 2 is a factor of 10 because it goes into 10. We can divide 10 by 2 perfectly. There's no decimals or anything like that. A factor of, let me think, 27. 9 is a factor of 27 because we get 9, 18, 27. It goes in perfectly. Okay, and you could put an example if you wanted. So, i.e., well, we could use that one, isn't it? 9 is a factor of 27. And I'm also going to briefly look at what a multiple is, okay? Because this is going to be helpful for something we're going to do in a little while, but it is connected to this. So if we look at it now, because they do always seem to come hand in hand. So a multiple is a number in the times tables of another. So it's almost, we always see these together and people tend to think of them as being opposites. Factors and multiples are opposites. They're not exactly opposites, but they're they're related. So for example, 27 is a fact. Sorry folks, it has been a while since we've made these. It's a multiple of 9, okay, because it's in the 9 times tables. Equally, 64 is a multiple of 8 because it's in the 8 times tables, okay. So think of a few of those, write yourself some examples, it's always helpful. Now I'm going to look away because factors, we're going to look at factors for now. We're not going to concern too much about multiples, but we will look at them more in a little while. Now factors are finite, that means they end, okay, that's the opposite of infinite, which goes on forever and ever. Factors are finite, so we can list them all. So if I ask you to write down the factors of 24, I don't want a few of them, okay, I don't want you to kind of just put a couple. I want all of them because you can do all of them. And the way we do it is to be really organised. And this is one of the big things in maths, organisation. So what we do, I want to look at all the numbers that go into 24. And you might be able to think of some. You might think, well, 6 goes into 24 and 12 does. But if we do it like that, it's a bit higgledy-piggledy and it's really easy to miss some. So I'm going to show you a nice, neat way of doing it. We start off with the number 1 and people always forget this one. But 1 is a factor of 24. 1 is a factor of everything. It goes into all numbers. And it has its other half. 1 multiplied by what is 24? Okay. And actually, 1 multiplied by 24 is 24. So that means 24 is also a factor of 24. Okay. So people often miss those ones. 1 and itself, but they're always factors. The next number we're going to look at is 2. 2 goes into 24, doesn't it? It's an even number. And what would we multiply 2 by to get 24? We'd multiply it by 12. So 12 is a factor of 24, because 12, 24, it goes in twice, doesn't it? How about 3? Does 3 go into 24? It does. It goes in 8 times. So that means 8 is also a factor. And if you lay it out like this, it's nice and neat and organised. How about 4? 4 is a factor of 24 and it goes in 6 times. Okay, so 6 is also a factor of 24. What about 5? Does 5 go in? Because we've got really lucky so far, they all go in, all the ones we've looked at. Now 5 doesn't go into 24, and we can see that because it doesn't end in a 5 or a 0. So 5 isn't a factor of 24. The next number we come to is 6. Now, we've already got 6 in here, so that means our numbers have kind of met in the middle, so we've finished. That's all the factors of 24. We've not missed any out. Okay, so it's a really nice, neat way of doing it. How about this one here then? Let's just try another example. I'd write this one in your book, please, if you haven't already done that one. Factors of 35. So we're going to start the same way with 1 and 35. Okay, they're the first two you should always get. The next one's, how about 2? Now 2 can't be a factor of 35 because 35 isn't even. So we won't write that one down. 3 isn't a factor of 35. Now the way I can see that is because I know 3 is a factor of 30 because 3 multiplied by 10 is 30. And so 30, 33, 36, it doesn't go into 35, just gets totally missed out. So 3 isn't. 4, again, it's an odd number, not even. So 4 isn't a factor. 5 is though, isn't it? So we've got 5 multiplied by 7, which is 35. The next number, 6, again, 35 is an odd number, so 6 isn't a factor. And then we get to 7, which we've already got, so we've finished. So don't be fooled into thinking because the number's bigger, it should have more factors, okay? That's not how it works. So work through nice and logically. So that's how we find all the factors. Now it's important you can do that because the next thing we come on to are writing, can we see all of that? Writing 24 as a product of its prime factors. Okay, that is supposed to say ours. I don't know why there's such a big gap in between the A and the S. Write 24 as a product of its prime factors. Now, this is exactly the way it would be written in a test or in an exercise book or something like that. That's how we'd write it out, this question. And some people, they know how to make a factor tree, and that's what you have to do this. But they get into a test and they see this fancy piece of writing and think, oh, I don't know what to do. Okay, and if I'd said to them, do a factor tree, they go, oh, I can do that, yeah. But we have to make sure we're familiar with this kind of language, okay? So write 24 as a product of its prime factors. Product, you need to remember this, means, what is product? So we see the word sum quite a lot, and we see the word product. Sum is when we added things together. Product is when we multiply them together, okay? So that's just an important word to notice. We'll see a little bit more about why that is at the end, okay? So the first thing I'm going to do, I'm going to do it on this half because I'm going to do 2 of these actually. So 24. And what I'm going to do, I'm going to think of a pair of factors, okay? So I could even look back at the ones we just did because we used 24 there. I'm going to choose a pair of these. Now I'm not going to choose 1. And the reason I'm not going to choose 1 is because I keep getting left with 24 and I could do it again and get 1 and 24. That's not going to help me. So I'm going to, let's say 2 and 12, okay? I'm going to do 2 and 12. I'm going to come down here like a little tree. 2 and 12. And then I look at those 2 new numbers I've written in and I think, are either of them prime numbers? And 2 is a prime number. And just remind yourself, a prime number is a number that only has 2 factors, okay? So 1 and itself. And that's 2 is actually the only even prime number. Okay, it's one of my favourites. Okay, so this branch is finished now because it's got a circle. So we're going to come over here and now we're going to look at some factors of 12. Now I need a factor pair. I need 2 numbers which multiply together to give 12. So a nice one. Again, I quite like these ones, but we're going to go another 2 and a 6. We don't need to make it overcomplicated. We know 12 is even, so it must be divisible by 2. And once again, we've got another prime number there. Okay, so I'm going to circle it off. And I'm going to carry on. Okay, so the 6, what multiplies together to give 6? We've got 2 and 3. And actually both of those are prime numbers. So now all the branches are completed. Okay, and the way we write our answer to this is 24 equals 2 times 2 times 2 times 3. Okay, and now the really smart cookies out there might have thought, hang on, that's a bit long-winded, there's a better way, and there is a better way. We could have written 24 equals 2 to the power 3 multiplied by 3, because what we get here is 2 multiplied by 2 multiplied by 2 is 2 cubed. And we can write it. It looks a bit neater, doesn't it? And we call this index form. Okay. We call it index because actually, do you know when you do bid math and we have indices? Okay. Index is the let me just put another arrow there. Lots of arrows here. It's the singular of indices, okay? And indices are all little things up in the air, okay? So index is just a singular of indices, and we call this index form. Now, the reason we had, I've gone off the screen a bit there, this word here, multiply, where I've written to product, okay, is because actually if we do this calculation, we do get 24, okay? It works. So we could do 2 cubed, but I'm going to work from this one here because it's easier to do in your head. So 2 multiplied by 2 is 4. Multiplied by 2 is 8. Multiplied by 3 is 24. Okay, so we know it works. Now, I'm going to do one more for 24 as well over here, because sometimes people think, well, how do I know I've picked the right factors? Okay, and the nice thing about this is that actually it doesn't matter. Okay, it doesn't matter. There are no correct factors. As long as they are factor pairs, it will work. So instead of 2 and 12, I'm going to say, let's go for 3 and 8. Okay, 3 multiplied by 8 is 24. That's a factor pair. 3 is prime, so I can kind of stop that one there. 8, that one will branch off now. We could have 2 and 4. Okay, and 2 is a prime number. And then the 4 becomes 2 and 2, doesn't it? So we actually get the same numbers at the end. So regardless of which factor pairs you choose, you will get to the same answers. So don't panic about that. So yeah, these are quite nice. People really enjoy doing these. I certainly enjoy doing them. It's nice and neat and organised, isn't it? One to watch out for if you have a 6, a really, really common mistake is people split that into 3 and 3. I think because 4 becomes 2 and 2, because 2 add 2 is 4 and 2 multiplied by 2 is 4, and people just, if you're rushing, you might get 3 and 3 under 6, but of course 3 multiplied by 3 is 9, isn't it, not 6? So just be careful. It's just one to watch out for. Okay, I'm going to do one more of these. Okay, one more set of factor trees. It's a bigger number this time. We've got 72. I'm only going to do it once because I think we've just seen that it will work regardless of which numbers you choose. So we've got 72 at the top. Now then, let's have a think. A nice pair. If you're not sure, because sometimes it's a bit tricky, you could write out some of the factor pairs at the side. If you can't think of anything off the top of your head, that's okay. You could also think, it's even, so it must be divisible by 2. So 2 multiplied by what is 72? Okay, it's another way of doing it. I can see here actually that it does split into 8 and 9. Okay, it's in the 9 and 8 times tables, isn't it? So neither of those is prime. Okay, so what we do, we carry on both of those branches. So we'll start on the 8, and that becomes 2 and 4. And look at that, we've got a prime number there already. We'll circle that one off. And the 4 becomes 2 and 2. So now we've finished all the branches on this side. We're going to go back up to the top and see if we've missed any out. So we haven't finished off this one, have we? And 9, actually quite a nice one, becomes 3 and 3 because it's a square number. 3 and 3. So we're going to write our answer as 72 equals 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3, and then in index form, because it's really nice if we can do this extra little bit, in index form that becomes 72 equals 2 cubed multiplied, don't get mistaken and put a plus in there, we're still multiplying it, multiplied by 3 squared. Okay, and you can check it. So 2 multiplied by 2 is 4, multiplied by 2 is 8, multiplied by 3 is 24, and 24 multiplied by 3 is 72. So you know it works, okay? And we've only got prime numbers in here. Now, you might wonder why are we bothering to do this? And it becomes really useful when we're looking for highest common factors of pairs of numbers, or lowest common multiples. But I'm going to cover that at a different point, okay? I want you to practice doing these for now. So have a go at them, try it with some numbers of your own, and if I've been in touch with you, I will send you some practice questions as well. Okay, thank you.